Okay, on this video, I'm going to focus on part 2, page 3, questions 17 through 24. There's a few questions here that rely heavily on parallel and perpendicular, so you want to make sure you understand the difference. Parallel means our slopes are exactly the same. Perpendicular, opposite reciprocal. That means if it's a fraction, you flip it. One's positive and one's negative. So an example I have here, parallel, slopes are the same. Perpendicular, if I were to turn this into a fraction, I would get 2 over 1. So when I take the reciprocal, it becomes 1 over 2. And it's opposites, meaning I have one's positive and one is negative. So if I take a look here at question 17, I'm only looking at the slope. Here I can see the slopes are exactly the same, which means they are parallel. When I go and I look at number 18, I have to first move my 7x over to the other side. I do that by using the inverse operation, leaving me with y equals negative 7x, and I don't need the 0. So now I see I have a negative 7 and a 1/7. They are opposites because one's positive and one's negative, and they're reciprocals because if I were to turn this into a fraction, I have a 1 in the denominator, and when I flip it around for the reciprocal, I get that 1/7. So these are perpendicular. Another thing that you could do to determine if slopes are perpendicular would be to see if the slopes have a product of -1. So if I were to take my -7 and multiply it by that 1/7 for this other slope, you should get a -1 if they are perpendicular, which we do. You're going to have some questions where you need to make sure you understand the difference between the x-axis and the y-axis and which ones would be parallel or perpendicular. What I recommend that you do is you go ahead and you draw in a coordinate plane and you label it. Plot the point that was given. So here, -1, 2. That means I'm going to go back 1 and up 2. And if I want it to be parallel to the y-axis, my y-axis goes up and down, which means this will also need to go up and down. Because it's a vertical line, it's not a function. So it's not y, it's not touching my y-axis at all, just the x, and it's touching at that x value of -1. 20 is the same thing. I recommend, since we're talking about the y-axis here, if I go ahead and I draw my x and y-axis and label it, I'm going to go ahead and plot where that point would lie. Okay. And this time, we want that point to be perpendicular to the y-axis. So the y-axis goes up and down. Perpendicular would go left and right. So it makes that 90-degree angle. Here, it's not touching my x-axis at all. So I'm not going to have any x's as my answer. And it's going through at the y value of 2, which matches that point. Okay, going over to 21. Focus is parallel. Parallel, same slope. So I have a slope right now of 2/3. I'm looking for 2/3. So it's not F, it's not H, and in this one it's not J. Because I also needed to go through this point, you would want to make sure, in case there were other answers, one way to do that would be to graph it. So I'm going to go ahead and type what I believe is my answer. And then menu 5, 1 to trace, and I'm going to type in the x value, and I see it has that matching y. Oh, you missed it. Okay. So you graph, menu, 5, 1, and then you press that value because it will automatically tell you the y-intercept. So you just type over and it will tell you. Okay. You can also use your point slope formula. So we're looking at the point slope formula. I'll go over your point slope for question 22. In question 22, this time we're looking for a perpendicular slope. That means if my current slope is -1/2, a perpendicular slope is going to be opposite. So if it's negative, I'm looking for a positive. And if I take the reciprocal of 1/2, so I flip it around, I get 2/1 or 2. So I'm looking for my slope. All of my answer choices are in point slope form. So I'm looking at 2. This is -1/2. It's not going to work. -1/2, not going to work. And this one is also 2. It's asking to go through the point of 2, -3. So my point slope formula says y minus y1 equals m times x minus x1. This is my x1 and my y1. So if I put y minus my y1, which is a -3, equals my perpendicular slope, which is 2, times x minus my x1 value, which is 2. My minus negative turns into a plus. And then I have a -2. So the only one that matches is D. Okay. We're going to have some transformations. You can also use your calculator to help you out. We're given f of x equals 3x minus 2, and we want to translate it 4 units to the right. If we're going to the right, that means that's a change in those x values. So we're looking at inside the parentheses. And so this is where I say inside the parentheses, if we're looking at that f of x, inside is the x values, it's always the opposite. Outside is the y values, and that's going to be what it means. So x value is going to take place inside, so it's not C and it's not A. And it's going to be the opposite. So if I want to go 4 units to the right, where it would be a positive, it's really going to be a minus. Okay? So on 24, this is outside. That's the y value. And it's going to be down 3 because it's a minus. This is inside, so it's changing the x values. So the x values, left and right, it's always doing the opposite. So even though we're wanting to say that it's stretching, it's really being compressed, a vertical horizontal compress. C, inside's the x values. I have a +5, so it's instead of going right, it's really going to be left 5. And then the 2 is taking place outside. That 2 is a larger number, so it's going to, and it's the y values, so it's going to be a vertical stretch. Okay. D, I have that negative, so it's a reflection. Now, if I have a point, inside my x values change. So x is left and right. It's going from the right side over to the left. So it's going to be a reflection of the y-axis. H, now this negative is on the outside, so that means my y value is going to change. So from the top, it would go from the bottom. That's going to be a reflection of the x-axis, because it's the x values that are changing. And then since I have this +2 outside, that's also changing the y values. And y value, anything outside, it's going to go up 2 units. Okay. If at any of these you would like to use your calculator, you can do that. So just kind of real quick, if I go to graphs, these are all going to be transforming the parent function, which is x. And I'll just go with question 1 here. So if I press tab and I'm using my calculator to kind of help me out, I'm going to do F1 because that's where I stored my first equation, was under F1 of x. And then I'm going to do parentheses x close -3. When I press enter, I can see it has moved down those 3 units.